All right, for Algebra 2, we're starting with Chapter 4, and so we're getting into matrices. So today we're organizing data with matrices. And I'm going to pause for a second. I got to get my tool. Okay, sorry about that. I had to get my pen. All right, so our objectives, we're going to start including these in our notes so we kind of know where we're going each day. So first up, we're going to identify the specific elements of a matrix because it's a brand new unit, something I don't think you guys have ever done before. Never even heard of it. Okay, so a matrix, let me look at this then. A matrix is one, right, like the movie. Matrices is just means more than one. Uh, it's not similar to the movie at all, although you might feel like you're in a different world. We're going to determine the dimensions of a matrix. We're going to use multiple representations of data arrays. So we're going to make matrices today out of different kinds of graphs and data arrays. And then and that goes into 4. We're going to create a matrix representation for vertices of a geometric figure. So we're also going to take them out of the coordinate plane, a geometric figure that's graphed on the coordinate plane, and make a matrix. So now matrices are cool because they're used to quickly solve systems of equations, which is awesome. And they help graphic artists and computer programmers edit, render, and manipulate images. So pretty much any animations that you see, like on the computer screen, there's matrices behind them. Okay, so it's this kind of cool math that you're like, what? When am I ever going to use this? That you've done that without knowing it. Okay, nice. Yeah, Lauren. Okay, let me pause this real fast here. Okay, so let's move on down here to what a matrix actually is. All right, so the matrix is a rectangular array of numbers. So we've got this example over here. Okay, so we've named it matrix M. So each number is called an element or an entry. So 2 is an element, 4 is an element, 6, 3 is an element, 7 is an element, 5 is an element. So element is each number. We name it with a capital letter. So again, this is matrix M. It's arranged in rows, which are horizontal, and columns. So, and that's how we name it, is how, or it's like that's how we talk about its dimensions as well, which is down here. Okay, the dimensions are given in the form of M, the number of rows, and N, the number of columns. I have no idea why it's M and N instead of R and C, but that's the way it is. Maybe it's some Latin. Yeah, it's M and N, you said? Yeah, M and N. Probably if you added and got 15. Okay, so this one we have 2 rows, right? 1, 2, so it's a 2, and then we have 3 columns. 1, 2, 3, so that's why it's a 2 by 3 matrix. Okay, and the last thing, because the dimensions are important, like when we look at them, because there's certain ways when it comes to addition and multiplication and things, subtraction, only certain ways we can, or certain matrices we can add or subtract or multiply or divide. And the last one is it's enclosed in brackets. So the matrix is always in a bracket. Touche. I should really get out the red as well. I'll use those colors specifically today, red and blue. Maybe this whole unit while we're talking about matrix. Then they're often notated with the, so we name it, right? It's matrix M, and then it often has the dimension of the matrix. So 2, 3. Okay, so oftentimes you'll see that. And it might be, again, whatever the name of it is, and go from there. So let's jump in to an example and see what we've got there.
I'm assuming there's a reason the numbers are in the way they are, like 246 and then 375. Why not 357?
Because it is, so again, it goes back to the fact that these are a simplified way to solve systems. So we could actually take a system, and this would be 2x plus 4y plus 6z, and 3x plus 7y plus 5z. Like we're pulling them straight from.
It's not just like, oh, we put them in random.
Yep, they're not random. And you'll see more of that later today, like when we kind of piece out, like figure out how we make the matrix. Yeah, so right now we're starting with the matrix and just identifying some parts, and then we're going to make one, and you're going to be like, oh, there is order to this. Like, we don't get to put the numbers in there however we want. That's a good question. I like it. Okay.
We're gonna make some deja vu by changing the matrix.
We are. We are. Okay, so
I'm gonna make a bunch of references to those movies. It's gonna be
good.
great.
I'm fine with it. So it says state the dimensions of each matrix. So again, we name it according to how many rows and columns it has. So it's got 4 rows, so it's a 4 by 3. So this is the answer. The dimensions are 4 by 3, and we read that as 4 by 3. B is called a row matrix because it's all in a row. But how many rows does it have? 1. So it's a 1 by, and how many columns? 1 by 4. That's its dimensions. C, okay, is a square matrix because it looks like a square. How many rows does it have? 2, right? 2 rows across. By how many columns? 2. So it's again a square. What might another square matrix look like? What might its dimensions be?
4 by 4.
A 4 by 4 would be a square matrix.
Wouldn't just a square matrix be any even number equaling by itself?
Yep. Mm-hmm. You got it. What would another row matrix be? What would the dimensions of a row matrix be?
1 by 1, 1 by 2.
Yeah. 1 by 1, 1 by 2, anything that just has the one row.
Yeah.
Excellent. All right, so then D is a column matrix because it's just a column. So how many rows does it have?
3.
So 3 rows by how many columns?
1.
1. So what might another column matrix be? Its dimensions.
7 by 1.
A 7 by 1, sure. Okay, you got it. So those are just some characteristics that you might see too, like take this column matrix or this row matrix so you can describe it. So far, so good?
I think so.
Think so? Okay,
I
perfect.
have the feeling I'm gonna get confused. But
Probably not today. That'll be tomorrow. All right, so then one other thing.
hold on, I forgot to be writing that down.
Oh, okay. Yeah, don't forget to write it down.
I don't want
Okay, so now also we have to have ways to talk about the elements inside the matrix. So subscripts are used to identify the elements in a matrix. So the element in row 2 and column 3 is expressed as A23.
Bingo.
Are you lost now?
A little bit.
Okay, so this is, so we always do row column, right? We always list everything as row column.
Yeah.
So this one, this point here, it's the element in row 1, column 1.
Oh,
And now this is the element in row 2, column 1.
Okay.
Okay, so this is the element in row 2. Sorry, it should be row 3.
Yeah. It should be 32.
Hold on, did I? Okay, let me pause this and let me go back. Okay, yeah, so in those, I flipped it. So it should be, let's fix this. And you need to fix it in your notes. I'm glad I caught it. It should be element in row 3, column 2. So change that, row 3, column 2.
Okay.
Because this one is the element in row 2, column 3.
Yeah.
Okay, so that's what all those little subscript numbers mean. And so we're going to, in example 2, we take that out. It says state the value of each element in the given matrix. So B, because this is B, okay, matrix B, and row 1, column 1. Well, that's this one. Row 1, column 1 is 3. So what element do we have in row 2, column 3?
14.
14. Very nice. Okay, so that's 14. How about C? What is our element in row 4, column 4? 8. Very nice. And the last one, row 3, column 1. 12. Questions there?
No.
No? Okay.
I was like, why are we putting powers
Yeah, right.
on A's?
Yeah. And that's why. And so it just depends on how it's named. So this would be, and maybe I should say like this is matrix A. So that's why it's AA, where this was matrix B. So we want B1, 1. All right. Now,
Because if we have more than one matrix, like we have an A
yep.
matrix and a B matrix,
Mm-hmm.
and it's asking us for a B matrix, we can't be looking at anything else.
Correct.
Okay.
Yep. If we had an A and a B matrix, if it said like B1, 1, then yeah, we need to be looking at the B matrix. Mm-hmm. Good call.
Is it gonna give us ones where it's like how it says B11 equals 3, but it gives us two different matrices and we have to find which matrix it's
No,
in?
no,
No.
no. This is just identifying the parts, because this is not where it gets hard. It gets hard when we're adding. We're going to add matrices, and we're going to subtract them, and that starts tomorrow.
And is that just gonna be like we take the B11 plus the B44, so it'd be 3 plus 8, kind of?
Kind of. We're gonna, yeah. After we get to the end, I might show you.
Smile
Right. Well, I mean, like,
slightly.
because it's like, because we would have another. So it'd be like if we took. So if we were doing addition here. So let me clear this. Uh, So if we were doing addition here, we would have to take the same place. Like this number is in the same place as this number. And so we would add those two numbers together.
Okay.
Okay. So it's like we overlay them on top of each other,
Okay.
and then we add the numbers that are stacked that correspond. Yeah, it gets a little different with multiplication and division. Scalar multiplication is awesome, you know. But again, so we'll start addition and subtraction tomorrow. But this today should not be where it gets difficult. Today is just kind of understanding what the matrix is. But it tomorrow won't be too difficult. It'll be Wednesday when I come back that we'll get a little harder. I'm just being honest. Yeah. Okay, so the cool thing about matrices, and this is like one of those things that like it's not always taught, but it is awesome. We can take data from graphs, charts, tables, spreadsheets, whatever, and they can be put into matrix form. Okay, so the calculations and manipulations can be done in all different ways. So in example 3, we're going to translate the data into matrices. Then we're going to state the values that are listed and what each element represents, which might seem like weird. Yeah, we're going to put them in the motherboard to transfer them to the matrix. Okay, so this is going to be, we're going to name it P, the matrix P, and it should be a 2 by 4 matrix. Okay, good question. Okay, so if we look at our data, we're looking at 2 months. We're looking at January and February. So that's going to be our 2. So when I wrote this, I went ahead and put January over here and February over here because I want to put my P equals in my brackets. And then with that, we also have 4 weeks of data. So because it said it's a 2 by 4 is how they want it, I did my 2 this way and my 4 this way. So week 1, week 2, week 3, week 4. Okay, so that's not part of my matrix. It's just helping me organize how I'm going to put it in my matrix. So in January, which is actually the first one here, so each of the first one is January, because when it copies, it's hard to see. But this number this week is 5. This January comes over here to 8. January on week 3 comes over here to 3. And the January for week 4 is 2. Does that make sense where all those come from?
Yes.
Okay. Okay. Then let's look at our February numbers. All right, so February, week 1 is 6. Week 2 for February is...
That's January.
Oh, thank you, that's January. Nix that. February, I was like, it should be, is 7. February for week 3 is 9. And February for week 4 is 4. We just made our matrix.
That's not bad.
Okay, perfect. So then, well, let me clear all this. we were supposed to identify a couple parts. So I wanted to find P12. So remember that's P in row 1, column 2. So row 1, column 2 is 8. Okay, so that's my number. That's the value. And then what it represents. Okay, well, we're talking about Katie's music practice. So this is the hours that she practiced each week of these months. So 8 is how many hours Katie practiced during the second week of January. So P23 is, actually let me change colors here, is row 2, column 3. So 1, 2, 3, which is a 9. And so this is the hours that Katie practiced during the third week of February. Make sense? Perfect. Yeah, I don't know. Who knows? All right, so let's, Katie. That's true. Katie knows. All right, so let's look at this other one. So we've got this one. So we had a graph, right? Bar graph. Now we've got a table, like in a spreadsheet. We've got summer camp, scripture memory challenge, and the team points. So we want to name it. It is already in the form of the matrix, right? Like we just have to like put the brackets where they belong, and it's like done. That's pretty sweet deal. I like it. Okay, and so they want it in that 4 by 3. So did it meet that need? We have 4 rows, 3 columns. Great. Okay, so since that's the case, so yeah, so I did the matrix part for us. But again, it's kind of already done, so that'll help you. So what is the element for S24?
Wait.
So column, row 2. Oh, wait, hold on. I'm sorry. I don't know what I was thinking. It should be, let's make it 2, 3.
Okay.
Yep.
Is this a trick or?
It's not a trick. It's a typo.
Okay.
That happens.
2, 3. That's 4.
2, 3 is 4, right? Row 2, third column. So that value is 4. And what does that value represent?
Let me look at this thingy.
Uh-huh. Look at the chart up here. Right? Because that would be this number right here.
It would be the number of points green team gained in day 2 of summer camp.
Okay, so the number of points green team gained day 2. Good. All right, so how about what is the element for S43? Okay, so S row 4, column 3 is 12. And what is that?
Number of points green team gained in day 4.
Good. So number of points green team gained, day 4. Perfect. All right, the last one, which is all up to you guys. I've worked it out a little bit. Okay, is we want the matrix for W, and we want it to be a 2 by 5 matrix. So I went ahead and named it, put our brackets in, and I did give you a little bit of help. I said A, B, C, D, and E. So what do you think the two rows are going to be? X and Y, yeah. So I'm going to write an X over here and a Y over here. So point A is
-2, 2.
okay, so I put the -2 in the X column and the 2 in the Y column.
B is
-1, -2, good.
C is 0, 0.
Oh, C is 0, 0. Nice catch.
I was like, wait. Oh.
Because it's just the origin.
D is
1,
-2.
-2.
E is 2, 2.
E is 2, 2. Perfect. Jacob 2, 2.
Yeah, it's an old TV show I used to watch with my
Oh,
grandma.
okay. I was like, I don't know the reference. All right, so do you understand? Okay.
It wasn't very popular.
Okay. So do you understand like the order to the matrix now? Like you asked that, like the questions are random or the numbers are random? Definitely not random. Okay. So then what is element W15? So 1, 5.
2.
2. Good, because it's the first column and the fifth row. And how about element 2, 3? 0, because it's the second row and third column. Good.
Don't know what they stand.
Yeah, they don't really represent anything except for a point. So that's okay. And that's actually only one value. Well, I guess we could. So this one, let's look at W15. 2 is the
X value of E.
x value, yeah, of E. Okay, and what's 0? It's W23.
0 is the Y value and X value.
Yeah, but in this case, it's the
Y
Y value, okay, of point C. Good. So we do know that. I just didn't, I forgot that step when we were doing it. All right, questions for today.
I think I got it.
All right, well then that's the matrix to get us started.
Going to get confused later on. I guarantee it.
You might get confused in your
But
homework, but it shouldn't be too terrible.
oh yeah.
You know,